All right, let's rationalize the denominator. We have here a fraction root 5 over the square root of 10. You'll notice the denominator, the lower part here, is not rational. Why? Because it's got that house there. It's a radical, it's a surd, it's not a whole number. We need to change this from a radical surd into a whole number that's rational. And the reason why we do that is because it makes calculations easier. So what's the first step we need to do in order to rationalize that denominator? Well, all we have to do is multiply top and bottom by the square root of the denominator. So let's go ahead and do that. So let's multiply by the square root of 10, because that's what that is, top and bottom. Square root of 10 on the top, square root of 10 on the bottom. So that's all we have to do. Now, the good news with the denominator is if we multiply by itself, we end up getting a rational number. So, for example, the square root of 10 all squared equals 10. That's rational. That's what we want to get there. Another way of thinking about it is root 10 times root 10. That equals root 100. And root 100, the square root of 100, is 10. Again, it's a rational whole number. There's no house on it. And that's what we want to do here. So the square root of 10 times the square root of 10 equals, on the bottom, we end up with just 10. Like that. Now, on the top, we got a house over the 5, a house over the 10. We multiply these two guys, so it's going to end up becoming a 5 times 10 is 50. Now, because both of them have got a surd on top of them, that means that's going to have a surd on it. So it's root 50 on 10. Now, the good news is we have now rationalized the denominator. The denominator is a rational number. It's a 10. But can we further simplify this? Yes, we can. We can actually simplify it because we need to first simplify that root 50. How do we simplify the root 50? Well, let's have a look here. If we have the square root of 50, we can simplify it because we can find two factors or two numbers that multiply to give us 50, so we can simplify it. So we want one of them to be a perfect square. So what's a perfect square times another number that'll give us 50? Well, it's going to equal square root of 25 times the square root of 2. 2 times 25 is 50, so there are your two numbers. And the good news is the root 25, that is a perfect square. That's a perfect square. Okay, why? Because the square root of 25 is just a 5, so we end up with 5 times root 2. So now it's simplified. So square root of 50 is simplified to 5 root 2. So let's replace that right there. Let's take 5 root 2 and replace it up here. So that equals 5 root 2 all over our rational denominator, which is 10. Now we can further simplify that even more. Let's see how much further we can go. Well, 5 root 2 on 10, is there a number we can divide top and bottom by so we can eliminate or reduce it a bit? Well, 5 divides into 5 and 5 divides into 10. So let's divide top and bottom by 5. So I'm going to divide that by 5 and divide this by 5. So 5 into 5 gives us 1, so that cancels. 5 into 10 goes in 2 times. So on the top we just got a 1 and a 2. So bring down the top. It's just 1 times the square root of 2. It's just 1. There's a 1 there. 5 into 5 is 1. So it's 1 times root 2, which is the square root of 2. All over. Down the bottom, 10 divided by 5 is just 2, so we put a 2 on the bottom. And now it's simplified and the denominator is rational. So the square root of 2 on 2 is a simplified and rationalized denominator. So root 50 on 10 is correct, it's still rational, but root 2 on 2 is the same, but it's simplified.